Welcome to 8.1 Notes Intro to Polygons and Interior Angles. Okay, so let's go ahead and start this. So we've got three different polygons right here. We've got A, B, and C, and all of these guys are polygons. Now, notice you might see something different from A than you do with B and C. See this angle right here. See how this angle seems to be kind of caved in here? It's not pointing out like the rest of these angles, right? Well, there's a special name for that, and we call those any polygon with an angle that's caved in, like this one. We call it concave. Now, it can still be a polygon if it's concave. It's just a concave polygon. With the rest of these guys are known as convex. And convex just means that all of the angles are pointing outward. This angle's pointing outward, this angle's pointing outward, all of these angles are pointing outward. These are polygons. They are polygons. Let's look at the ones that are not. Ugh. Okay, these are definitely not polygons. They're just ugly. Alright, well, with polygons, you shouldn't have any curves. We do not want curves on our polygons. No curves, right? But what about gaps? Do we want gaps in our polygons? No. No gaps in our polygons. Polygons are closed figures, right? And last but certainly not least, we do not want any cross over of any of the lines. If you have a line that's crossing over itself, guess what? You're not a polygon. Okay, now polygons can't have curves, they can't have gaps, and no crossing over of the lines. So let's put this in our little bullet points here. Polygon, a plane figure that is formed by three or more segments called sides, such that the following are true. Formed by line segments only. Segments only. No curves allowed, right? No curves. Boom. Okay. Number two was it's got to be a closed figure. Closed figure, right? That means no gaps. No gaps, no openings. And last but certainly not least, that segments don't cross each other. Segments don't cross each other. All right. So those are three of our rules for what is and what isn't a polygon. Okay, let's look at now what a convex polygon is. We talked about that above there. A polygon that's convex means just that all angles point where? Outward is correct. All angles point outward. Okay, an example of this would be boom, 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 boom. Okay, no inward pointing angles. Okay, concave polygon is not all, guess what, angles point outward. Alright, an example of this is boom, 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 boom. Okay. We've got a cave in. Cave in. Concave. Get it? Cave in? Okay. So now we're going to classify the polygons by number of sides, alright? And the first one, come on, we know the three sides. Let's zoom that in. Triangle, right? A triangle is a polygon with three sides. 4 sides is no, not so fast. Not a square. A 4 side is a quadrilateral. Quadrilateral. Why isn't it a square? Well, squares have equal sides and equal angles. Quadrilaterals, not so much. Okay, 5 sides. 5 sides is a pent. Pent means 5. Gone. 5 sides. Agon is 5 sides. 6 sides is hex. Agon. Gon means side. 7 hepta. Gon. Pentagon. Hexagon. Heptagon. Alright? Now guys, if I'm going too fast for you, then just pause this and write this in, okay? 8 sides, they're coming after me. 8 sides is octagon. Let's do this in a different color, why not? Octagon, like the Octomom. 9 sides is nona. Gone here. 10 sides is deca. Gone. And then 12 sides is do, deca, gone. So if you're following along here, and that's do for 2, that's deca for 10, and that's gone for 12. So do, deca, gone just means 2 and 10, and gone for sides. So do, deca, gone just means 2 and 10 in sides. Now, here's the funny thing about these, is that whatever other side that you may have, let's say that you have, a 14-sided figure. Guess what that is? That's a 14agon. If you have a 137-sided figure, that's a 137agon. If you have an 11-sided figure, that's 11gon. I don't know why 11 just kind of got left out of this 10 and 12 business, but what are you going to do? Okay. Name polygons using consecutive vertices. Alright guys, now let's take a look at this. Don't be a goofball. Start with one vertex and work your way around the polygon. Okay. You should be able to, when you're naming the polygon, you want to be able to not lift your pencil off the paper. So if you start with W over here, then your polygon's name is W, S, T, U, V. W, S, T, U, V. So polygon, that's our little shape, our little thing for polygon. W, S, T, U, V. Now, you could start at T, and you could say, and you can even go backwards. T, S, W, V, U. Polygon, T, S, W, V, U. Okay, you get the picture, right? But here's what you can't do. You can't start it up here and go, S-U-V-T or W-V or anything like that, alright? None of that. Okay. Let's continue on. Okay, now we're talking about regular polygons here. A regular polygon. So, regular polygon. Now guys, make sure you understand what this word means. Regular means it's a polygon that is equilateral, and also equiangular. Alright. So, our regular triangle, it's equilateral, 1, 2, 3, all 3 sides, 1, 2, 3, are equal, and all 3 angles, 1, 2, 3, are equal as well. So what is that called? well, that's just called an equilateral triangle, right? Boom, equilateral triangle. Our regular quadrilateral. Alright, I want you guys to think about this. Go ahead and draw a regular quadrilateral on your paper. Try it. I'll wait. Alright, regular quadrilateral. Quadrilateral has 4 sides to start off with. Ooh, look at that, that's pretty good. And then we know that the sides are all equal, right? But it's not some crazy like rhombus where all the sides are equal. That is not a regular, that's not a regular quadrilateral. Why? Because also all of your angles have to be equal. And only one shape has all these things in common. That is your square. Alright. So too, we've got the interior angles of polygons. So we're going to draw diagonals from a single vertex until the polygon is separated into non-overlapping triangles. Okay. And then we're going to complete the table below. Alright, let's look at this triangle here. Well, here's a vertex of the triangle, and really we can't draw to any other vertex without actually drawing on the triangle side itself. So, how many triangles do we have in here? 1, right? Well, that's not very fun. Let's take this one. Remember, we're just going to pick a vertex right here. We could pick any of the corners or vertexes, but we're just going to pick that one. And we're going to draw to the other vertexes. Well, this one, okay, well, that's not very fun. But to this vertex, we separate this shape into 2 what? Triangles. 1 triangle, 2 triangles. Okay? Let's take a look at this next one. If we pick, let's pick the top as a vertex here. We could pick any of their corners, but we'll draw our diagonals out like that. Look at that. How many triangles is that? 1, 2, 3. Notice our pattern yet? Let's pick this vertex. We're going to draw our diagonal from each vertex that we can. And now how many triangles do we have? We have 1, 2, 3, 4. Heptagon. Boom, 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 boom. And 1, 2, 3, 4, 5 triangles. Alright, well, we've got all our triangles right here and all our polygons, and they're asking us to fill out the rest of this table here. So we got number of sides for our triangle. Number of sides for triangle is 3, and number of angles, that's 3. Number of triangles we have is 1, right? Total degrees in one triangle, well, total degrees in a triangle is just 180. Remember, if you add up all the different angles, then you get 180. And so the total degrees in the polygon, well, we just said it. One triangle has 180 degrees in it. Well, let's look at the quadrilateral now. We've got 4 sides in the quadrilateral. 1, 2, 3, 4. And our number of angles is also 4, right? So the number of triangles in here we said was 2. Okay? And the total degrees in one triangle, well, total degrees in one triangle is still going to be 180. But this time, we've got total degrees in the polygon. Well, guys, look. If we have one triangle that has 180 degrees, and then we have another triangle whose angles add up to 180 degrees, all of those angles added together are going to be 180 degrees times what? 2, right? Because 2 triangles. Okay, so 2 times 180 is 360 degrees, right? Pentagon. Penta, why, I know that. That means 5. So 5 sides. How many angles? 5 angles. You notice a pattern there. Number of sides always equals the number of angles. Boom, 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 boom. Okay? Number of triangles, well, we said that there were 3 triangles in our pentagon, times the number of total degrees in one triangle. It's always going to be 180. 180, 180, 180, right? Okay. 3 times 180. Alright, all you math geniuses out there, 3 times 180, quick. 540 degrees. Aha! Okay, hexagon here. 6 sides, 6 angles. How many triangles? Well, you just take that 6 minus 2, right, and you get 4 triangles. 4 times 180. 4 times 180 is 720 degrees. And last but not least, we've got our heptagon. Hepta, that means 7 sides, 7 angles. And then remember, we basically just take our sides minus 2 to find out how many triangles there are. That's the pattern, if you haven't guessed it already. 5 times 180 is, drumroll please, 900 degrees in a heptagon. In any heptagon, all of the sums, now make sure you understand what I'm talking about here, all of the interior angles add up to 900 degrees. I'll say that again. In a heptagon, all of my interior angles add up to 900 degrees. And how can I know that? Because I have 1, 2, 3, 4, 5 triangles, each with 180 degree angles in them. Okay, so what's our pattern here? If you have n sides, that's going to equal n angles, right? And for the number of triangles, that's just going to be however many sides you have minus what? A 2, right? And then however many that is, you're going to multiply times 180 degrees, because that's how many degrees in each of your triangles, and that's going to give you 180 times n minus 2. So however many sides you have, this right here is going to be the equation for the total amount of degrees in your interior angles. Alright? All of your interior angles in your n-sided polygon are going to add up to this. Okay. So, the sum of the measures of the interior angles of a convex polygon are 180 times number of sides minus 2. The measure of one interior angle of a regular polygon. Alright, so think equiangular. All of your angles are going to be the same. So you might have an interior polygon, you might have a regular polygon that looks like this, right? All of your angles being the same. Okay? Is going to be, we're going to bring this down. It's going to be 180 times n minus 2, so that's the entire sum of that's the sum of the measures of all of your interior angles, and then you're going to divide that by the number of interior angles you have. Well, in this one you have, in the square you have 4, so you would have divided that by 4. Okay, so let's put this to use. I know it may not make complete sense right now, but let's look at an example and see if an example helps out. I'm going to keep my angle right there, my equation right there. Example 1 says, find the sum of the measures of the angles of a regular nonagon. So we know that regular, everything's going to be equal, right? We know that non means 9. And we're looking at the sum of the measures, so all of the measures. Also find the measure of one interior. So we're actually going to use both of these. We're going to use this guy first to find the sum of the measures, and then we're going to use this guy to find 1. Okay. So first, 180 times, well, we said it was 9 sides minus 2. So remember how we got that. We just got that from here. 180 times n minus 2 equals, well, that's going to be 180 times 7. And what is 180 times 7? 1,260 degrees. Okay, so that is the sum of the measure of all angles. Sum of angles, right? So how would we find one of these angles if it's a 9-sided figure? We're going to divide the sum by 9, and we'll get 9 by 9 angles here. We'll get what each one is. So 1260 divided by 9 is going to equal 140 degrees per angle. 140 degrees per angle. Alright, now try this. Find the sum of the measure of the angles, okay, we've done that before, of a regular decagon. Also find the measure of one interior angle. Okay, you're looking for the sum of the measure of all of the angles of a regular decagon, and then the measure of one interior angle. So go ahead and try it. I will give you a hint. Use that. Okay? Go ahead and pause this and try that and see what you get. Okay, let's take a look. So we started with 180 times n minus 2, and since this we're dealing with a decagon, we're talking about 10 sides. Deca means 10. Alright, so we got 8 times 180, and that turned out to be 1,440. And so that's the sum of the measures of all the angles, right? That's all of them. Now, we've got 1,440 degrees divided by 10 angles, because we want to know how many, what the degrees are for one interior angle. And so we divided that, and we get 144 degrees per angle. Now remember, this only works with a regular decagon. The amount of degrees per angle only works with a regular decagon. Okay. Example 2. Find the missing measure of the hexagon to the right. Okay, here's our hexagon to the right here. And we have to find the missing measure. Alright. Well, we know that it is a hexagon, and so we know that the equation to find all of the sum of the angles is going to be 180 times, it's a hexagon, so 6 minus 2 is going to equal the sum of all the angles, right? So you work that out, and that turns into 720 degrees equals the sum. Just to make sure, 720 degrees equals 98 plus 143 plus 106 plus 147 plus 125 plus whatever this is right here. And so we're actually going to add up all of these together. And so when you add up 98 plus 143 plus 106 plus 147 plus 125, you get 619. So I know that the sum should be 720, and that the total of all of my angles except for this one is 619. So I just subtract what I know all of my angles are from 720, and I'm left with 101, which is this measure of this last angle. Alright? Okay, so that is it as far as this goes. If you had any problems with understanding any of this stuff, just go back and take another look and ask during tutorials and when we're going through the homework. Thanks.